Hello friends, welcome to my channel. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning CBSE Class 12, Chapter 1, Relations and Functions, important questions, that is, previous 5-year questions from the year 2016 to 2020. So, this video is for marks 4. Question 1. Let n be the set of natural numbers and r be the relation on n cross n defined by a comma b related to c comma d if this represents if and only if. Okay. Find only if and only if a into d is equal to b into c for all a comma b comma c comma d belonging to n, show that r is an equivalence relation. So here what is said over here is that n is a set of natural numbers, we know it already, and r is a relation on n cross n. Okay, so here it is given that a comma b is related to c comma d if and only if a into d, that is a into d, is equal to b into c. They have not given any numbers, just with variables they are saying that a d is equal to b c for all a comma b comma c comma d belonging to n. So what we have to do here is that we have to prove it is an equivalence relation. So what is equivalence relation? It is reflexive, symmetric and transitive. So this question was asked in CBSE in the year 2020, and also this is an NCERT question, that is miscellaneous example 42, example number 42. This type of question is there, that is only the variables are changed over here. Okay, so now let's see the solution. By the end of the solution, I'll give you the marking scheme for the solution. What is given here is that we have to show that it is an equivalence relation. No, so just if we just prove it is reflexive, symmetric and transitive, that's enough. So we need not to do anything with that. So now directly we can just start finding. So for reflexive, so we have a comma b related to c comma d. No, so for reflexive we have a comma a belonging to r. Yes, so I will say that here a comma b is one term. Okay, consider like that, so that I'm saying that a comma b is related to a comma b itself. Yes, see, a comma b belongs to r, we say, if only one term is given. So since here two terms is given, okay, I'm taking this full term as one term and saying that a comma b is related to a comma b itself. So what I will get here is that here a comma b c comma d is this, so I have a d. So this first term and last term, then second term and first term. Yes, so I will be just writing it as a b is equal to these two terms. B A. Anyhow, AB is equal to BA. Yes, so therefore it is reflexive. Therefore, R is reflexive. Symmetric. So for symmetric, I will take it as it is. So that is a comma b is related to c comma d. So directly I can just write, no? So what is given in the question? AD is equal to BC. So let me have this. Okay, this belongs to R. And here also you can just belongs to R. Then I'm just saying that this implies C D is related to A B, This also belong to, you can just write it belongs to R, or else the relation is anyway, it is N cross N. So you can write like this also, N cross N or else R. In these two, any one you can just write. So this implies that these two terms, now C and B is equal to D and A. So anyway, AD, DA both also same, BC, CB both also same. So I will just write that these two are proved. So therefore R is symmetric. Now for transitive. So I will just say for the first as it is, so A comma B belongs related to C comma D. So this belongs to N by N, and this implies AD equal to BC. So next I will say that C comma D is related to E comma F. You can take any variable, no? So I'm just taking E and F belongs to N cross N. So this implies that these two variables, first variable and the last variable in the second term, no? So C and F is equal to these two now. So DE. So here we have to check for the third only, no? So I will take this A, B and EF. So A and B is related to E and F. I will just check, then only say that it belongs to N or not. So what I will do here is that I will be marking this as equation 1 and this as equation 2. That is my first condition as equation 1 and my second condition as equation 2. So what I will do is that I will be writing my equation 1 as it is. That is AD is equal to BC as it is. Second equation, so equation 2 is equal to this as it is, okay. LHS will be multiplied with LHS and RHS with RHS itself. So AD into CF is equal to BC and into DE. So now if any terms are common here, I can just cancel it out. So I have A. Do I have A in RHS? No. So D I have here, D I have here. So I can just cancel it, or else you can just bring it to the LHS or RHS and you can cancel. And C is over here, C is over here also. So F is here, F is not here. So you can just stop with that. So my left out terms are A and F is equal to B and E. So now I will be checking for this one. So A is the first term for this and F is the last term for this. So therefore I will say that it is of the form AD is equal to BC. If you just carefully look into the given condition, the given condition is satisfied. So therefore I will say that this also belongs to N by N. So this implies I can just write the same condition over here. AF is equal to BE. Therefore, R is transitive. So since R is reflexive, symmetric as well as transitive, I will say that hence the given relation R is equivalence. It's very short answer, I guess. See, only we are just proving it is reflexive, symmetric, transitive. That's it. Nothing more than that. So in this you can easily score 4 marks. So now let me give you the marking scheme for it. So if you write till here proving it is reflexive, no, so you will get 1 mark for that. So next for proving it is symmetric, you will have 1 mark, and next for proving it as transitive, you will get 1.5 mark totally. Okay, so why 1.5 mark means to prove this this is extra over here, na? So for every transitive sum you will have 1.5 mark, and proving it as equivalence you will have 1/2 a mark. So here totally you will have for 4 marks. Question 2. Check whether the relation R in the set N of natural numbers given by relation R is equal to A comma B such that A is divisor of B. That is, B divided by A gets some integer value. Is reflexive, symmetric or transitive. Also determine whether R is an equivalence relation. So what is given here is that the relation R is given. So this is the given relation, and we have to check whether it is reflexive, symmetric or transitive, and at last we have to check whether it is equivalence relation or not. So this question was asked in CBSE 2020. So now let us see the solution. By the end of the solution, I will give you the marking scheme. Solution. So directly we can just start checking for reflexive. So reflexive, here I will say that A comma A belongs to R. That is, A divided by A gives some integer value. No. So therefore I will say that A comma A belongs to R. Therefore R is reflexive. Next, symmetric. So I will say that A comma B belongs to R. Okay. So then I will just say that, so for example, just consider 1 comma 2. Okay, so this belongs to R. So it means that 2 divided by 1 gives me 2, which is an integer. So then just check for 2 comma 1. So this means it is 1 by 2, which is 0.5, which is not an integer. So therefore I will say that B comma A does not belong to R. So therefore R is not symmetric. Okay. Now let's check for transitive. So transitive, A comma B belongs to R. So the same example, if we just take 1 comma 2, it belongs to R. No. So then I will say that you need not to give any examples, since we have to prove that without numbers we can't just prove. So only for those types of sums you will be using numbers. For these, you need not to. Just check with some numbers. If it is satisfying, then you can just proceed with variables. So B comma C also belongs to R, I'm just saying. Then this implies, so this is divided by this, and this also is divided by this. So this, then automatically it says that A also divides C. Okay, so therefore I will say that A comma C belongs to R. So you can just give the reason as A divides B and B divides C, hence A divides C. That's it. So therefore R is transitive. Here R is reflexive, R is transitive, but it is not symmetric. So hence I will say that R is not an equivalence relation. So only that is asked. So I can just stop with this. So even here the solution is very small, but still this question is for 4 marks. So these types of questions is very easy to score the solid 4 marks. So now I'll give you the marking scheme. So for just proving it till here, that is reflexive, it is 1 mark. Next here till prove for symmetric, for proving this you will get 1 mark. Okay, so next for proving it as transitive you will get 1.5 mark. And for proving it as equivalence or not equivalence, here we have proved it is not equivalent, no, so therefore it is for half mark. So you can just stick on to this marking scheme and answer the questions based on it. Question 3. Show that the function f from minus infinity comma 0 to minus 1 comma 0 defined by f of x is equal to x divided by 1 plus mod x, where x belongs to minus infinity comma 0 is 1 to 1 and on to. So what is given here is that the function, okay, the function from minus infinity comma 0 to minus 1 comma 0. So here what is minus infinity comma 0? It means some number from infinity to 0. So where it is opened interval, so these two are not included. So therefore it means that the domain for this is always negative. So the domain is always negative and the range is between minus 1 and 0 only, always. Then what they are saying here is that f of x, that is the function f of x, is x divided by 1 plus mod x. So here also it is given that x belongs to minus infinity comma 0. It means x is always negative. What is there between minus infinity comma 0? Negative numbers. So I will just have negative over here. So mod x will be negative. So when we remove mod x, no, we will get minus x. Okay, so this is what the thing, and we have to show or prove that it is 1 to 1 and on to. So now let's move on to the solution. And first let us see for 1 to 1. So as we do for the other sums, we will just start saying that let x1 comma x2 belong to the domain only we will be writing, no, so the domain over here it is minus infinity comma 0, such that f of x1 is equal to f of x2. So now we can just directly substitute here. So my f of x is x by 1 plus mod x, no, so x1 divided by 1 plus mod x1 is equal to x2 divided by 1 plus mod x2. Okay, so now I will be removing the mod. If I remove the mod, I will get negative of that x, no. So I will have x1 divided by 1 plus into minus is minus. So minus x1 is equal to, here also the same, 1 minus x2. So now I can just cross multiply this. So x1 into 1 minus x2 is equal to x2 into 1 minus x1. So I will be just multiplying this inside. So x1 minus x1 x2 is equal to x2 minus x1 x2. So since I have x1 x2 and minus x1 x2 over here, anyway if I bring it to my RHS, I will have minus x1 x2 plus x1 x2, no, so directly I can just cancel it over here itself and say that x1 is equal to x2. So therefore since x1 is equal to x2, I will say that f is 1 to 1. Next for on to. So as we do for other sums, for every x belonging to minus infinity comma 0, there exists y belonging to minus 1 comma 0. Yes, so therefore I will write that f of x is equal to y. So what is my f of x? It is x by 1 plus mod x. No, so therefore it is equal to y, and I will be removing the mod. I need not to have mod and all those. So x divided by 1 minus x is equal to y. So I will be just cross multiplying. So x is equal to y minus xy. So now I will be having my x terms in one side. So x plus xy is equal to y. So I will be just taking x common out. So 1 plus y is equal to y. So therefore x is equal to y divided by 1 plus y. So now my value of x is y plus y divided by 1 plus y. So now I will be just saying that f of x is equal to f of what is my x there? Y by 1 plus y. So now I will be just substituting over there. So it is x by 1 plus mod x. No. So in each place of x I will be substituting this. So y by 1 plus y divided by, it is minus x. No, so 1 by mod x minus, so minus, and here it is y by 1 plus y. So I will have y by 1 plus y as it is in the numerator, and I will be taking LCM for this. So I will have 1 plus y minus y divided by 1 plus y. Since my denominators are same, I will be cancelling these two, and plus y and minus y will get cancelled. So I will have y as it is. So therefore, since my f of x is equal to y, I will say that therefore f is onto. So hence it is proved that it is 1 to 1 and onto. Now let me just give you all the marking scheme for this. So now if you just prove for 1 to 1, you will get 2 marks. Then if you prove for onto, you will get 2 marks. So now for writing all these steps, for all these steps till here, you will get 1 mark. Okay, so if you just complete all these steps, again you will have 1 mark. So for on 1 to 1, 2 marks is over. Now for onto, so here till here, no, so writing all this for every x belonging to minus infinity comma 0, so till here if you write f of x and is equal to y, so you will have half a mark over here, and next for writing it till here you will have half a mark. Next, for writing this one, so f of x is equal to f of y plus 1 plus y. So till here you will have one half a mark. Then for ending this question, you will have one half a mark. So this is how the marks are splitted. So there are step marks. You can't just say that there is no step mark. There is step mark. So that is what I have given it over here. So you can just stick on to the marking scheme and just answer according to that. Question 4. Show that the relation R in the set A is equal to 1, 2, 3, 4, 5, 6 given by R relation is equal to A, B such that mod of A minus B is divisible by 2 as an equivalence relation. That is, a set A with numbers 1 to 6 is given, and also they are saying that the relation A comma B, the mod of A minus B is divisible by 2. That is, if we just subtract these two numbers A and B, it should be divisible by 2. That is what they are saying here. So now we have to prove it is an equivalence relation. So now let's start doing the sum. Solution. So first reflexive. So for the first one, let me take a comma a itself. This belongs to R. Y means a minus a is equal to 0. So 0 is divisible by 2. So therefore, R is reflexive. Okay. So now, symmetric. So symmetric a comma b belongs to R. So this implies that if a minus b is divisible by 2, then it means that b minus a also divisible by 2. No, so therefore I will say that b comma a also belongs to R. So therefore R is symmetric. Transitive. So if I just say a comma b belongs to R and b comma c belongs to R. So if a comma b is belonging to R, that is a minus b is divisible by 2. By 2. And b minus c is also divisible by 2. And this implies a minus c is also divisible by 2, no? So therefore I will say that a comma c also belongs to R. Therefore R is transitive. Hence R is reflexive, symmetric and transitive. Hence R is equivalent. That's it. So the marking scheme for it is, so if you just do till here reflexive, it is 1 mark, and for symmetric the same 1 mark, and for transitive it is 1.5 mark, and for equivalence it is half a mark. So question 5, if f of x is equal to 4x plus 3 divided by 6x minus 4, x not equal to 2 by 3, show that f of x is equal to x for all x not equal to 2 by 3. Also find the inverse of f, that is f inverse. So here the function f of x is given here, and we have to show that f of x is equal to x, and we have to find the inverse of it. So now let's move on to the solution. So now directly we can just do with the first part of the question. So let this be second part. So my first part is f of x. So what is now I will be splitting, that is f of x only is f of x. So I will write f of, what is my f of x? That is 4x plus 3 divided by 6x minus 4. So since whatever is inside the bracket, we may consider that as x. No? So I will take my x as 4x plus 3 divided by 6x minus 4 in the next step. So what is my f of x again? So then it is 4x plus 3 by 6x minus 4. Yes, so now I will be substituting the value of x in each and every term here. So I will have 4 into, what is my x here? It is 4x plus 3 divided by 6x minus 4 plus 3 divided by 6 into 4x plus 3 divided by 6x minus 4 minus 4. Okay, so this is numerator and this is denominator. So now we can just start simplifying. So I will be taking LCM over here in numerator as well as denominator and multiplying this inside. So I will have 16x plus 12 plus 18x minus 12 divided by 6x minus 4. This is my numerator, and my denominator 24x plus 18 minus 24x plus 16 divided by 6x minus 4. So in my denominators, I have same. I can just cancel these two. So here also I can cancel minus 12 and plus 12 and 24 and minus 24x. So I will have 16 plus 18. It is nothing but 34x divided by 34. Okay, so now I can just cancel this 34 and 34. So what is remaining? It is x. So hence it is proved that FO f of x is equal to x. Okay, so now what is the second part? We have to find the inverse. So since FO f of x is equal to x, it is proved that FO f of x is equal to I. Okay, that is f is equal to f inverse. So if FO f of x is equal to I, then we say that f is equal to f inverse. The function is inverse of itself. That's it. So the marking scheme for it is, so if you just write till here, that is f of FO f of x and f of x, and just write the f of x, first f of x, you will get 1 mark. Okay, so next, after simplifying all those, if you just find till here, you will get 1 mark. So accordingly we will be just splitting it, and for proving this FO f of x as x, you will have half a mark. So till here, only till here you will have 1 mark. Then for proving it as FO f of x as x, you will have half a mark. So now you will have 1 mark for this. That is showing that since FO f of x is equal to x, I'm saying that FO f of x is identity function. So therefore I'm saying it as f is inverse of itself. So therefore I will have half a mark. If you have any doubts, mention it in the comment box. If you have not subscribed my channel, subscribe it and also click the bell icon.
Like, comment, share and subscribe.